A world of crimson deserts, towering volcanoes, and mysteries that have captivated humanity for centuries. Is there life? Could we survive there? This is the story of the Red Planet. Past, present, and future. Welcome to Live Documentaries. Long before rovers, Mars was a symbol of war and mystery. The Romans named it after their god of battle, while 19th century astronomers like Percival Lowell imagined canals built by alien civilizations. Today, we know the truth is even stranger. Since the 1960s, over 50 missions have dared to unravel Mars's secrets. From the first dusty images of Viking 1 to Perseverance drilling for ancient life, each mission brings us closer to answering, was Mars ever alive? And now, private companies like SpaceX aim higher, to make humans a multi-planetary species.
To 4 nautical miles.
It brings so much closure to what you've been doing that you have to be happy about that.
Just coming up on 2,000 miles per hour, passing T plus 60 seconds. Our solid motors have burned out.
But until you see the launch vehicle separate and spin down,
like a nice crisp jettison from the fairing,
and turn on the star scanners and exercise its propulsion system, find out where the temperatures.
EDL is the most complicated and dangerous part of any mission trying to reach the Martian surface. In a matter of minutes, multiple spacecraft transformations have to take place. It begins with separating from the cruise stage. Next, the rover, enclosed in a capsule, hits the atmosphere at 12,000 miles per hour. 4 minutes later, the speed has been reduced to 1,000 miles per hour, slow enough for a supersonic parachute to deploy without shredding. Then the heat shield jettisons, and the lander begins rappelling down a metal tape and a rope bridle. Meanwhile, a computer is calculating information about motion and altitude. Only seconds remain before the airbags inflate, the rockets fire, the metal tape and bridle rope are cut, and the lander free falls to the surface. The first bounce could be as high as a 4-story building, followed by more bounces that could go on for half a mile before the lander, with the rover tightly wrapped inside, comes to a rest. Hopefully, in one piece. There was still more bad news coming from Mars. On Christmas...
A fleet of robotic spacecraft is exploring the Red Planet, and scientists are finding new ways to mine an ever-growing mountain of data. Satellites always orbit a planet's center of mass, but they can be pulled slightly off course by the gravity of massive features like Olympus Mons, the solar system's tallest peak. Now, a team of scientists at NASA's Goddard Space Flight Center has used small fluctuations in the orbital data of 3 spacecraft to map the gravity field of Mars. In this new map, low-gravity canyons like Valles Marineris in blue stand out from the high-gravity reds and whites of the Tharsis Mountains. By comparing gravity with topography, the scientists made an improved estimate for the crustal thickness of Mars, shedding light on its geologic history and confirming earlier indications that the planet has a molten outer core. The orbital data also revealed seasonal variations in the mass of the polar caps, showing that up to 4 trillion tons of carbon dioxide cycle annually between the poles. The new gravity map should prove useful to future missions as well, by allowing spacecraft to enter orbit more precisely, thus ensuring that the Mars fleet continues to return a massive trove of data.
Did life ever exist on Mars? Billions of years ago, Mars had rivers, lakes, and possibly even an ocean. Today, rovers like Perseverance search for fossilized microbes, clues to a once habitable world.
Perseverance is exploring Jezero Crater, where an ancient lake and river system once existed. If microbes ever lived here, signs of them could be preserved in these rocks. About 3.5 billion years ago, a river carved a canyon through the crater rim, filling the crater with water and depositing sand and rocks that formed a delta. On Earth, the record of such an ancient river and lake would have been erased long ago. That's why sending a robotic explorer like Perseverance is so valuable. Mars is a special place that preserves a unique record of things that happened in the first billion years of the solar system. In this area, different rock layers record different parts of the crater's history. The flat, light-colored rocks were deposited on the banks of a river flowing slowly across the landscape. The boulders in the distance were deposited later in what was likely a raging torrent. And if this peculiar outcrop caught your attention, it did ours as well. It doesn't look like sediment at all. Perhaps it's a remnant of a lava flow, now mostly eroded away. Lab equipment on Earth can accurately measure when a volcanic rock was formed, so if we can return a sample of this lava to Earth in the future, we may know when and for how long water flowed into Jezero. From here, Perseverance will continue west. In the distance, you can trace the tops of the natural levees that formed at the near and far banks of the river. The rover will pass this area on its way upstream, continuing toward this spot, where the river carved through the crater wall. You can see the canyon on the horizon here. From there, Perseverance will be well positioned to head south and ascend this natural ramp that leads up and out of the crater. We're lucky to have a route the rover can safely drive up the rim right where we need it. Starting the climb would mark a new and exciting phase of the mission, exploring rocks far older than those in Jezero and produced in an entirely different way. One tempting target are these light-colored rocks partway up the rim. They may have interacted with hot water in a hydrothermal environment, another exciting place to hunt for evidence of past life. Since finishing its study of the crater floor, Perseverance has been climbing the delta and piecing together the history of this once watery environment. We've come a long way in nearly 3 years of exploring and collecting samples, but there's still so much more to investigate.
Shaped by flowing water. In the distant past, Mars must have had a warmer, wetter climate. But scientists wonder, just how wet was ancient Mars?
So in the ancient past, we have some indications that water was flowing on the surface, but how much water was there? We're talking about oceans, are we talking about small rivers, little rain? So these definitions of how much water was on the planet was very undefined.
A major question has been, how much water did Mars actually have when it was young, and how did it lose that water?
To answer this question, a team of researchers at NASA's Goddard Space Flight Center used infrared telescopes on Earth to study water molecules in the Martian atmosphere.
We used the world's 3 major telescopes for infrared astronomy. From the ground, we could actually take a snapshot of the whole hemisphere of the planet on a single night.
The new infrared maps reveal the atmospheric ratio of normal to heavy water molecules at different locations and seasons on Mars. Heavy water molecules contain a heavy isotope of hydrogen called deuterium, which remains trapped in the Martian water cycle, while normal hydrogen is lost to space. The researchers found that water from the polar ice caps is highly enriched in deuterium, indicating that Mars has lost a tremendous quantity of water.
Now we know that Mars water is much more enriched than terrestrial ocean water in the heavy form of water, the deuterated form. Immediately, that permits us to estimate the amount of water Mars has lost since it was young.
The findings indicate that only 13% of an ancient ocean remains on the planet today, now stored in the polar ice caps. 87% of this ocean has been lost to space. This means that early Mars would have looked much different than it does today, with a significant portion of its surface covered by water.
So the really interesting question is, could it form a sea or an ocean? And indeed, it would. In the northern plains, which is a relatively flat region but depressed from the rest of the planet, it would form an ocean that was approximately 20% of the planet's surface area. And so that is a respectable ocean.
This ocean had a maximum depth of around 5,000 feet or around 1 mile deep. It's deep, not as deep as the deepest points of our oceans, but comparable to the average depth of the Mediterranean Sea.
By combining Martian topography with the new estimate for water loss, the researchers were able to simulate Mars's ancient ocean and its escape to space. As Mars lost its atmosphere over billions of years, it lost the pressure and heat needed to keep water liquid, causing the ocean to shrink and recede northward. The remaining water eventually condensed and froze over the north and south poles, giving Mars the ice caps that we see today. This new scenario means that Mars would have stayed wet for longer than previously thought, expanding its ancient habitability.
We now know that Mars was wet for a much longer time than we thought before. Curiosity shows it was wet for 1.5 billion years, already much longer than the period of time needed for life to develop on Earth. And now we see that Mars must have been wet for a period even longer.
It's fascinating that we can learn so much about 4.5 billion years ago when measurements are taken right now. And ultimately we can conclude this idea of an ocean covering 20% of the planet, which opens the idea of habitability and the evolution of life on the planet.
But surviving Mars won't be easy. Deadly radiation, minus 80 degrees Fahrenheit temperatures, and toxic soil stand in our way. Yet visionaries are already planning solutions. 3D printed habitats, terraforming the atmosphere, and even modifying human DNA. Is this our destiny? Mars is more than a planet. It's a mirror. It reflects our curiosity, our resilience, and our unquenchable thirst to explore. The red planet may one day be a second home, but for now, it remains the ultimate frontier. Stay curious. This is Live Documentaries.